Okay, reset. Up until now, we had a vertical asymptote and a horizontal asymptote. And we changed the definition of horizontal to be end behavior. End behavior of is in the form of a straight line. What other type of lines do you know? Yes. Sure. Yes, that's a little too much. It could happen, absolutely. So as opposed to a horizontal line, what other lines are there? It's a vertical line. Yes, it's a vertical line. Will? Diagonal. Y equals mx plus b. Right? What other lines do you know? Joseph? Yeah, parabolas. How about cubic? How about quintic? So on and so forth. Oblique asymptote means an asymptote that's not horizontal. That's all it means. So where will we ever see a situation where my end behavior is actually not this, but something else? And there's only one condition. Everyone ready? I'll say it twice. Oblique asymptotes happen when the numerator has a bigger degree than the denominator. That's it. I'll say it one more time. Oblique asymptotes are, and let me share screen here. Oblique asymptotes occur when the numerator's degree is greater than the denominator's degree. Nope. It could be, yeah, as long as it's bigger. Now we're going to do 1 to get used to oblique. It doesn't have to be 1.
1 is like one straight line.
Come take a look here. By definition, oblique is an umbrella term for all non-horizontal asymptotes. You will get a straight line diagonal asymptote if the degree is 1 greater. If the degree is 2 greater, x to the power of 2, you're going to get a parabolic end behavior. If it's x to the power of 3, you'll see something like this, so on and so forth. I'm jumping the gun. Let's try the simplest example, and then you can start wrapping your head around different shapes, yeah? Let's take it slow here. Example 3. Here is a function. So the only thing that I will say is this. Every single step is going to be exactly the same, but as x approaches infinity and negative infinity, the curve behaves more like a non-straight line than a horizontal. It behaves more like an equation, is what I'm trying to say. Okay, so let's try it. Please follow along. We're going to do everything exactly the same as before. Let's see if I can copy this and put it on Zoom. That is going to be, let me see if I made a mistake. It is a minus. It is a minus. Oops. Then let me clearing here. Plus 2 over. All right, so this is my question. Okay, 3x to the power of negative 3x to the power of 2 plus 2 divided by x minus 1. Let's do this. Okay, same steps as before. And I am recording, right? Yeah. Same steps as before. All right. Domain. X can be anything, but x cannot equal a 1. Same steps. Intercepts. Go for it. Let's do the y-intercept first. If x equals 0, what is f of 0? Well, that's 0 plus 2, 0 minus 1. So the x-intercept is 0, negative 2. What about the y-intercept? What if that equals a 0? Then that means numerator of negative 3x squared plus 2 equals a 0. That means negative 3x squared equals negative 2, and x squared equals positive 2 over 3. What's up? No, please, by all means, stop me because I am running on very little sleep again, like maybe about 3 hours today. So let me know. It is not by choice. And I don't have insomnia or anything. It's just, yeah. It was better than Thursday though. Yes. This is for the y-intercept. Sorry, no, this is for the x-intercept. So this is y-intercept. The bottom is left x-intercept. So notice how I made x equals 0. That's y-intercept. And here I made the y equals 0. That's x-intercept. So x is going to be plus or minus square root of 2 over 3. And if I want to graph this, it's better to know that this is approximately 0.82. I'm doing this only for the graphing because it'll help me graph. But if I want it as an algebraic answer, this is totally okay. Yes. Pardon? But when you square root, both possibilities have to be considered. Next. Okay, asymptotes. This is the big one. So if you're copying this down, I like you to put asymptotes and say, for vertical asymptote is the same, right? So here, new, okay? For vertical asymptote, it's still what values of x make the denominator 0? Get out of my way. Okay, x equals 1. For a horizontal asymptote, I'm going to type it in right here. Numerator degree is greater than denominator degree. Therefore, no horizontal asymptote. If you don't believe me, I'm just doing the work for you, but if you don't believe me, I invite you to try to simplify it. If you have negative 3 x squared plus 2 divided by x minus 1, and I factor out an x, what do you get? You get negative 3x plus 2 over x over 1 minus this. The fractions essentially become irrelevant. So all you have is infinity over 1. That doesn't tell you anything. It just becomes big. That's all it says. So you can't do it in a typical way. So here's my suggestion. We're going to look at its behavior by identifying what kind of equation does it exactly follow. Here's what I mean. You see this fraction? Can you divide it for me? If you divided it, what would you get? Let's go back to chapter 2. So if you want to do long division or synthetic, try it. Okay. So for oblique asymptote, so this is the new part. I am going to divide, so that's negative 3x squared, 0x plus 2, and the root is a 1. Pardon? It's a oblique asymptote. I'm really excited for you to see this. Like this will complete the picture. This is the final piece of that puzzle, and it'll make the picture complete. Think about it, everyone. I'll wait for everyone to copy. And once we get there, think about what we just did. What does f of x mean? And now that we're talking about oblique and end behavior, what would that turn into as x gets bigger and bigger and bigger? What's the implication of the remainder, especially? So remember, the whole point of me doing this was to figure out what oblique asymptote was, right? What is the implication of that fraction as x gets bigger and bigger? What happens to that fraction? Yes? Yes. It gets smaller and smaller. So as x gets bigger and bigger, this part becomes irrelevant. So as x gets bigger and bigger, what shape does the function take? Mx plus b. As x approaches negative infinity and as x approaches positive infinity, f of x is going to be, let's do positive first, negative 3x minus 3. It's going to be a negative slope line minus 0, right? Minus a fraction. It's going to be minus 1 over infinity. Minus a small number. Sorry, Jess. Can you still see it? It's a minus. And then as x approaches negative infinity, this will still take the shape of an mx plus b, but minus 1 over negative infinity is like saying plus 1 over infinity. So it's going to look like negative 3x minus 3, but is it going to be above negative 3x minus 3 or below? As x approaches positive infinity, this is going to be slightly smaller than negative 3x minus 3. So it's going to be, I'm going to put a little minus there to tell me it's below. And this is going to behave like 3x minus 3. But because I'm actually adding a slight something as I go towards the negative side, this is going to be slightly above. I'll pause there while people are sort of soaking it in. I'm going to go through all of it again. We're going to do the chart, and then we're going to graph it. You're going to hate this, but afterwards, you're going to start feeling pretty good about yourself because this looks like, this is stuff that grade 11s cannot touch, right? Beyond them. And so you're going to feel pretty proud of this level. Yes. Yep. Uh-huh.
You can say that 1 over infinity.
Yes. What is subtraction of 1 to an infinite number? Nothing. Nothing.
And then between 0 because like 1 divided by infinity
It's so close to 0, you might as well consider it 0. But is it 0? Not quite. And since I'm subtracting, it tells me if I'm above or below. Just have to make that connection. All right, here we go. Once again, from the top. Denominator tells me that's my restriction. And not only that, it tells me my vertical axis. Intercepts. I plug in a 0, I get my y value. I make the y a 0, I get my x values. These are x-intercepts. That's my y-intercept. 3 points. Really nice. The vertical asymptote is the same. The horizontal or the oblique, only one exists typically. I don't think you'll ever see a situation where 2 will exist unless it's like ridiculously complicated with this not grade 12 level. Okay. Oblique asymptote is what I recognize in this question because the denominator is smaller degree. I will divide to figure out what equation or what function the entire curve will slowly behave like as I get bigger and bigger and bigger in x and smaller and smaller and smaller in x. Question? Nope, you don't have to. If you're just like, I don't need to write this because I recognize it, and you go straight to oblique, that's fine. I am going to make myself some space because I need it. Oh, geez. Okay, let's do a chart now. Chart. Let's see. My vertical asymptote is a 1, and my x-intercepts are negative 0.8, positive 0.8. And my equations are okay, let's do it. Smaller than negative 0 point something, I'm going to plug in a -1. -1 times -1, +1 times -3, -3 plus 2 is a negative. -1 minus 1 is a negative. So the entire function will be positive. A number between negative and a positive, I'm going to choose 0 because that's the easiest. 0 times 0 is a 0, times a -3 is a 0, plus a 2 is positive. And then 0 minus 1 is a negative. I don't know why I circled that. So the overall function will be a negative. A number between 0.8 and 1, 0.9, I guess. 0.9 times 0.9, 0.81 times negative something is a negative 2 point something, which is larger than a 2, that's a negative. Use a calculator, please. Negative 0.9 or positive 0.9 minus 1, that's a negative. This is going to be positive. And lastly, a huge number, that'll be a negative. A huge number, that'll be a positive. So to the right of the vertical asymptote is 8. If you want to try that yourself, please, I invite you to do so. All I'm going to do is clear some space so that I can draw a curve. Yep, go ahead, ask a question. You may wish to either make your scale super small or make your graph really big. An oblique asymptote will do something really funky and you want as much sort of drawing room as possible. I invite you to, I have to squeeze it in really, really tightly. So I actually invite you to draw your graph here if you want to, and then do the answers to example 4 and in a different piece of paper, okay? You want some space for this. You could, but you're gonna have to make your units very tight together to see how the oblique is. Try to copy what I do very carefully because I'm gonna try to make the scale small to fit it here. Is everyone ready for the graph? This is your first oblique. Everyone okay? You draw your scale? I see some lines, good. Okay, here we go. I have an x-intercept at negative 0.8. Positive 0.8, and I have a vertical asymptote at 1. That's a 1. I have a y-intercept at -2. Oh, what else do we know? Domain doesn't help us right now. Y-intercept, x-intercept, we have it all down. We have intervals. We have our vertical. What's the one thing we didn't draw yet? Our oblique. And what is our oblique? What is the end behavior? Good. It's a negative slope, so it's like this. It goes through -3 as my y-intercept. So find your -3 and do a slope of -3. So rise 3, 1 this way. Rise 3, 1 that way. So because this is a -3, 1, 2, 3, 1. It goes through that point. My oblique is in the form of, well, that's a terrible line, -3x minus 3. Let me see if I could draw that better. Yeah, it should be, yes. It's a linear. That is whew. Can't see it yet, right? Not quite. Let's add our end behaviors. As we get closer and closer to -infinity, am I above or below? I'm above that dotted line. So my curve should be somewhere here. And as I go closer and closer to positive infinity, am I above or below? So I should finish below the line. And then let's talk about this vertical asymptote. If I am to the right of the vertical asymptote, sorry, if I'm to the left of the vertical asymptote, my values are positive. So if I'm to the left of my vertical asymptote, I should be here. And then if I am to the right of my vertical asymptote, I should be put all, it's okay. Okay, got thick skin, not offended. Minus 10 points. It's okay, right? Guys, it's your first oblique. So yeah, it looks a little messed up. But if you did all the steps that you've been doing since 3.1, all that's left for you is to connect the dots. I have to start here. I have to hit the x-intercept, then the y-intercept, then this x-intercept before finishing off in this arrow. But as soon as I touch that vertical asymptote, you can say that you sort of teleport down here, and then I have to finish there. This vertical? This slope? Yes. That is my slanted, that is my oblique, that is my end behavior. And it starts here, and it needs to finish there.
The way we graph the line,
Hmm?
the way we graph the line, it's like, and so like if one, it's like -3 divided by 1 minus 10.
Yeah. You show me that this is your calculated equation, and you follow it. You might be asking, oh, Mr. Gan, how do you know that you don't cross it? I know I don't cross it because my end behavior, it automatically sends me underneath that line. If my calculation told me I have to go above this line, I'll probably do something like that. I might have to cross it so that I remain above, right? the calculation told me I have to stay below, so I don't think I'm going to cross it. This is my best guess. I don't think I'm going to cross it and I stay underneath.
That's what it looks like.
This is what it looks like.
This is on the.
Well, this is part of 3.6, so your mini test would be, sorry, if you had a big test, then this is fair game, oblique. I think I said that we're gonna have, next week, we'll have a
You said we had an
assignment, quiz, and then a test the week after, I think.
You said we have a
Quiz.
All those three things that they go. So we got some assignments Tuesday, with Wednesday, and then there was a class on Friday.
Oh, is it all in 1 week? That sucks.
That's so cool. Like, we're really tired.
We'll see. I mean,
So you told us you were gonna start teaching.
right.
Actually, okay.
Put it this way, that quiz, you could think of that quiz as like, it's gonna be like 10 marks. Okay, that quiz is on 3.1 and 3.2. So if you are able to do the steps for, 1 over x squared, it'll be okay, I think. But think about it that way, try to do it lightly. I would say the graphing assignment is gonna give you a lot more practice. If you keep up with the homework, you won't even have to study for that quiz on Wednesday, in my opinion. It's supposed to be a very straightforward, not tricky kind of checkpoint. Yes, Ian? Sorry, the calendar? Sure, I can do that in just a second. All right. It's on the bright space. Even I am forgetting the dates because I have to consider the other classes. Okay, this is our first exposure to oblique. When we come back, let's do one more. But before we leave, can we make an edit? In example 4, it says f of x is equal to the numerator being x squared minus 6x plus 7. Can you change that to a minus 7? Minus 7, please. So on your sheet, example 4, change it from a plus 7 to a minus 7. Okay. Once we come back, try to get some, downtime, decompress. And then when we get back, sit down and try the 4 DIAC steps for example 4, and we'll do it together. Okay. I am stopping the video here.